Start. So 6A, we're now moving away from fractions, decimals, percentages into ratios. But in order to do ratios, you do need to know your fractions, decimals, and percentages. What's the difference between writing a ratio and then a fraction? It's literally what we're describing. So here's an example. You got 3 parts here. Okay, so the number of parts we have in total is 3. But how many is shaded and how many is unshaded? Can I please have Osman? How many shaded and how many unshaded?
There's 2 unshaded and there's 1 shaded.
Good. So we say 1 shaded because shaded is on the left. So 1 for shaded. The colon, we say 2. So it's 1 to 2 ratio. That's the language that we use. All right. But if we talked about in fraction terms, out of 3 parts, how many out of 3 is shaded? Let's go with Mark. 1/3. So this, as a fraction, is 1/3. So when you write 1 to 2, there's a total of 3 parts. 1 plus 2 is 3. That 1 represents 1 out of 3 parts. Whilst this 2 represents 2 out of 3 that is unshaded. And that's just understanding that bit is 6B. 6B relies on the fact that you understand the fraction component. 6A is for you to be able to read a ratio. What's the difference between ratio and fractions? The ratio just focuses on the 2 key or 3 key quantities, but the units are not listed. So you notice when you say 1 to 2, you don't say 1 centimeter to 2 centimeters. It's not needed for the units. Same thing on this side. Let's do a bit of a quick one. So this one has 1, 2, 3, 4, 5. So that means 10 blocks in total. But out of 10 blocks, how many is shaded? 3. How many is unshaded then? 7, because 3 plus 7 has to add up to 10. So that means in terms of fractions, how many is shaded and how many is unshaded? Can I please have Quinn? 3 out of 10 is shaded, and then 7 out of 10 is unshaded. Does that make sense so far? So fractions are technically ratios, and ratios are technically fractions. In fact, each fraction technically is also a ratio. Okay, so it is 3 shaded to 10 parts. That's essentially what you're saying there. So for every 10 parts that are 10 parts, there are 3 that is shaded. Okay, so that's what you're going to be doing in exercise 3B, where you're going to apply the fractions to then solve problems. For now, you're just learning to simplify. So what are the skills in simplifying? So here's, just like fractions, we have equivalent fractions and we have equivalent ratios. How do you simplify them? Same thing. It is multiplied or divided by a given factor. So ratios can be multiplied, divided by a factor to give an equivalent ratio. What's an example? A 1 to 3 ratio is equivalent to, now you can see here, 3 became a 6. 3 is on the right, and that's a 6. How would I multiply or divide a number to get to 6 from 3? Times by 2. But to keep it equivalent, that means everything needs to be multiplied by 2 as well. Therefore, an equivalent ratio, 1 to 3, is the same thing as 2 to 6. If you are finding ratios confusing in terms of the layout, you might want to change it to a fraction. See, 1 to 3, like I said before, is the same thing as writing 1 over 3. Okay, because that's you can also write ratios as 1 to 3 or 1 over 3. It's the same idea. So that means if we keep the second number and the second number for this one, we can call it, this is 6, and the question is, what number is this? So that's another way of looking at it. I prefer you being able to read it through ratios, but if it helps you with fractions, this is another way to do it. So you can see 3 times 2 gets you to 6. Therefore, you can do the same thing on the top. That means the number has to be 2 to 6. What's important about ratios? The order does matter. So if whatever's on the left must stay on the left, which means if you use 1 as a numerator, it always has to stay in the numerator. If 3 is in the denominator, therefore it has to be in the denominator of the other one as well. So the right has to stay with the right, the bottom has to stay with the bottom. Okay? So you got 2 ways of looking at it. You can either look at it as ratios or you can look at it as fractions. Either way works. Both techniques will work the same way. Okay? Here's a quick example for 6A. So 6A is pretty straightforward. It's about you learning how to use ratios. So here in a bag, there are 3 green marbles, 7 blue marbles, and then 6 red marbles. Question is, if I have 3 green, 7 blues, and 6 reds, how many marbles in total do we have here? Can I please have Jay? There are 16 marbles in total. So there are 16 marbles in total. If I had to write a ratio of green to blue to red, so notice the order, green to blue to red, you have to write it in that particular order. So how many greens do we have? 3, so it should be 3. To blue, how many blues? 7, and then how many reds? Then it has to be 3, 7, 6. If you wrote it as 3, 6, 7, it'll be wrong. So whatever the writing is, you have to follow the writing in its order. So that's the main difference with ratios. Okay? Oh, it is too. Yes. Then let's answer part B, the ratio of green marbles to total number of marbles. So how many green marbles? 3, but the total is 3 to 16. Very good, because it says total number of marbles there. Okay? So green marbles, 2. So that's my 2. Total number of marbles is 16. Finally, ratio of blue marbles to other marbles. So blue, we currently have 7. But what's the other marbles? 9, very good, because I have, if 7's taken out, then I've got 3 and 6, which is the red and the green. Together, that is 9. That's exercise 6A as part of the first step. Hands up if you understood that bit. All right, that's pretty good. Next bit is simplifying. So this is going back to your fractions from the first chapter of what we did in this term. Simplifying. Let's flip over to the next page. I'll show you how to simplify. Flip over to the next page. Example 3. Simplifying, you have to find common factors. Now again, 8 and 20. You can look at it as a ratio, or you can look at it as 8 over 20 if you prefer. You're going to find a number that fits in 8 and 20. What is your highest common factor of 8 and 20? Harrison? 4, because 4 fits in 8. 2 also fits in 8 as well, but 4 is the highest common factor. So dividing both of them by 4 to make it equivalent. 8 divided by 4 gives me 2, and then 20 divided by 4? 5, very good. So it's a 2 to 5 ratio. Or you could have done it the same thing on this side. Divide this by 4, divide this by 4, and you get 2 over 5, which is the same thing as 2 to 5. Okay? Same thing as 2 to 5. All right. Now these ones are relatively easy. 21, 24, 8 and 20. It's the same skills. But the one that I find students struggle with is the next one. So let's do 4A. Students know how to do it when it's 8 to 20, but they will find it tricky when I give them a fraction to a fraction. Okay, so ratios with fractions. How do we approach this, Fraser?
You would multiply 5 times 6, and then multiply 3 by 6, and then multiply 6 by 5, and 5 by 1.
All right, very good. So, for those who weren't sure what Fraser's saying, get rid of the fractions. How do you get rid of fractions? You do the opposite of what you currently see. So if this here, what's this symbol mean again? Divide. So what am I dividing? I'm dividing by 5. So what's the opposite of dividing 5? Times 5. Very good, multiplication. So times 5 on the left. But whatever you do to the left side, you do to the right as well. So then I times this by 5. If you prefer the fraction form, which will look very nasty, this is what it looks like as a fraction form. So 3 over 5 over.
When you turn to the left side by 6,
Yeah, but you get the same denominator.
You will. So I'll show you what we're doing here soon. You can also times this by 5 and then times this by 5. Same idea. So whatever you do to the top, you do to the bottom. So if this is only if you prefer the fraction form, this is the ratios form. When you do 5 times 3 and then divide by 5, notice 5 and 5 have a common factor. What's a common factor? 5. How many 5s fit in 5? 1. And how many 5s fit in 5 here? It's also 1. So in a way, it cancels out to be 1. So you end up with 3, 2. Now 5 times 1 over 6 gives you 5 over 6. And now this is where Fraser was saying before, whatever you do to one side, see I've got that 6. This is a divide. This is 6. So opposite of divide 6 is? Times 6. So here you would then times 6 on the right. But whatever you do to the right, you do to the left. So times 6 as well. 6 divides 6. These two again eventually going to cancel out. So 6 and 6 have a common factor of 1. So 6 and 6 once and 6 and 6 once there. So it ends up being 5 times 1, which is 5. But then on this side, 6 times 3? 18. 6 plus 3 is 9. But 6 times 3. Addition. Yeah. So 18 to 5. Now you question yourself. 3 over 5 to 1 over 6 is actually equivalent to 18 to 5. This here, the question is, are there any common factors? No. So you leave it at there. This is your simplest form. So this is if you want to do it through ratios method. If you did it through fraction method, this is what it would look like. 5 and 5 becomes 1, so you end up with 3 on the top. This becomes 5, 6 on the bottom. And you want to get rid of that divide 6. You can times the bottom by 6 and times the top by 6. See, these two will cancel out. And so you end up with 18 over 5, which is the same thing as 18 to 5. Okay, so fraction method, I would say this gets really confusing for a lot of students. They may prefer this method instead. Yeah.
Could you make the denominator the same? So on the left hand side, make it because the highest lowest number is 30.
Beautiful.
And then make it 18 over 30 and 5 over 30.
Yep.
And then just do the 18 to 5.
Very good.
30 is like 0.
That's right. So for those who might prefer a second method, the reason why I did my method is that if you struggle with finding lowest common multiple, then my method will work for all of you. So you just do the opposite of what you see. But the most efficient way is like what Harrison just said. If you're able to figure out the lowest common multiple of 5 and 6, if you know where they're both in common, it's 30. Then all you have to do is just times 30 on both sides, and that will simplify your answer straight away. So 30 and 6 cancels out to be common factor of 6 and 30. 6 goes in 6 once. 6 goes into 35 times. Whilst over here, 5 goes into 5 once, and 5 goes in 36 times. And you end up with the answer straight away. 6 times 3 is 18, and 5 times 1, 5. So you get the answer straight away, but in order to do this, it means you have to know your lowest common multiple. Okay, and because I know that not all students know their lowest common multiples, that's why I taught you through this way. So even if you don't know your lowest common multiple, you can just literally do the opposite of what you see. So if the denominator is over 5, then you times it by 5. If you see denominator of 6, then times them both sides by 6. And that will always work. Okay? But yes, finding the lowest common multiple method will be the fastest way to get to your answer. Let's have a look at the next question then. What do you do if you have mixed fractions then? So if I've got 2 and 2/3 to 3 and 1/2, or 1 over 2, how would we simplify this ratio? Because in ratios, we always write in integers, meaning whole numbers. We never leave it as decimals, and we never leave it as fractions, the way we have right now. So what do we do?
2 times 3 times, 3 times 2 plus 2.
Very good.
3 times 2 plus 1.
Change it to improper first. Okay, so these ones are fractions or proper fractions. Change them to that you have a numerator and a denominator. So here we go, 3 times 2, and then plus the numerator. 3 times 2 is 6. 6 plus 2 is 8. So it'll be 8 over 3 as a fraction. So from mixed fraction to improper fraction. Next one, 3.5 is the same thing as writing 7 over 2. Very good. Now from here, you can use Harrison's method. Find the lowest common multiple of 3 and 2 and do it in one go. Or you can do my method, get rid of the 3 and then get rid of the 2 individually. It's up to you. Yeah, so I'm going to use Harrison's method. What's the lowest common multiple? 6. So that means you just times both sides by 6. When you do this, you have to be strong with simplifying it. So if we go 2 and 6, what's the common factor? Yes, so that becomes 3, but the common factor is 2. So 2 goes into 2 once, and 2 goes into 6 3 times. Then you look at this one, 6 and 3, what's a common factor? 3. So 3 goes into 3 once, and 3 goes into 6 twice. Very good. So that becomes 2, 1. So that means your new fraction, 2 times 8, 16. And this one is 3 times 7, 21. So you get your answer in one go. But if you weren't strong with this 2 bits that I just did, go back to how I taught you before. Rewrite this step here. So you would have 8 over 3 to 7 over 2. Then I would want you to do the opposites of what you see. So that's divide 3 times 3 on the left times 3 on the right. 3 and 3 will cancel out. So you end up with 8 to 7 times 3 is 21 over 2. How do you get rid of divide 2? Do the opposite of that. Times 2 to the right, times 2 to the left. And notice you get the same answer. It becomes 2 times 8 is 16. And 2 and 2 cancels out. You get the same answer, but it means you don't need to know the LCM. Obviously, if you know how to do LCM and simplify, that's the quickest way. This is your alternative. It's up to you. Hands up if that made sense to you. Okay, got a bit, maybe a half of you. All right, cool. That's the main skill of 6A. Okay, so 6A, as you're going through it, that's the main skill. All right, team. What I'm going to get you to do now is we're going to apply that. So 6B is to apply your understanding of how to simplify ratios. You don't always get fraction ratios. This is only for the tricky ones. You only need to know how to do these ones, mainly. Okay? So in 6B, we're going to use these skills and apply them into a situation. So flip over and I'll do one example, and that's it for today. Here we go. Let's go to 6B and do one example of how do you apply ratios into a problem. Here we go. We're going to do example 1. I'm going to just delete this bit. Here's example 1. Can we also change that 30 meters into dollars, just so it makes a bit more sense for you guys to start off with? Change it to $30. All right, here we go. Imagine you guys have $30, right? Now, what's this ratio of 2 to 3? Imagine you bought a ticket, a lottery ticket for $5. Okay, so a $5 lottery ticket. Let's say I chipped in $2, so Mr. Tran, T for Tran, chipped in $2 for the ticket. And then say, yep, Thages, TH, chipped in $3, so you chipped in more. Together, we bought a lottery ticket. And it just so happens we won. We won a total of $30. Why would it be unfair if we split it evenly? I get $15 for Tran, and Thages also gets $15. What's the problem?
They just paid more for the ticket.
Yeah, he paid an extra $1. But if I didn't know how to divide it equally so that he gets a certain amount out of it, I just say, yeah, let's do 15. Who cares about the extra $1 you spent? We did it together. But they're just like, no. I can do the maths. Let's actually work out dollar to dollar how much I deserve. So this is how you do it. If I want to do the contribution, I put in 2, he puts in 3. How much should we split so that it's fair for either person? Okay, is what you do. So let's think about it as a block. Out of a block of 5, 1, 2, 3, 4, 5. I chipped in 2. Thages chipped in 3. As a fraction, how much of $30 did I contribute?
2 out of 5.
2 out of 5, because there's 5 parts in total. I chipped in 2/5. How much did Thages chip in?
3 out of 5.
3 out of 5. And that's the only part you had to understand. So total number of parts, we knew there were 5 parts in total. So 2 to 3 has a total of 5 parts. But we know Mr. Tran contributed 2 out of those 5 parts, and they just contributed 3 out of 5 parts. So that means out of 30, I should get 2/5 of 30. So let's think about the language. 2/5 of 30. See, 2/5, you know that's a fraction. Of means times. 30, how do you write 30 as a fraction again? 30 over 1. Okay, so Your question?
No.
I know, okay. So from here, to work out the amounts, let's work it out. So 2/5 times 30 over 1. Let's work out how much I actually should get. Which two numbers can you see that I can simplify already? 5 and the 30. Always pick a number on the top and a number on the bottom. 30 and 5 don't do 2 and 30. They're both top numbers, so you can't simplify them. It has to be one top, one bottom. What number goes into 5 and 30?
6.
Good. So the answer is 6, but 5 goes into 5 once, and 5 goes into 30 6 times. So that means 2 over 1 times 6 over 1. What does that give me? 12. Because 2 times 6 is 12. 12 over 1 is the same thing as 12. So what that means is, out of $30, instead of getting 15, like I initially proposed, I should get 12. But if I get 12, how much is they just getting? 18, because that's the remainder. So you don't actually have to do the calculations here. You don't have to do 3/5 times 30. Since you know the total was already $30, if you're already giving Mr. Tran $12, then obviously they just has to get the remaining. So the remaining is 30 take away 12, gets 18. But if you're still wanting to practice your fractions, then from here you can work out 3/5 of 30, and then do the same thing again. That becomes 3 over 1 times 6 over 1, and you get $18. So they just gets 18, I get 12, and therefore 12 to 18 is actually the same as 2 to 3. Okay, so 2 to 3 is equivalent to 12 to 18. The difference is this is 5 parts for the ticket. This is 30 parts for the money. Okay, so this is 30 parts. Versus this is 5 parts. That's pretty much all you need to know how to do. Now you can do that for 3 ratios, 4 ratios, but just to start off with, you're practicing to do it with 2 ratios. Question?
Can you just add the ratios together and then divide it by that number and then just times it by each type of ratio?
Yes, that's another way that I see most students do as well. Since you know there are 5 parts, and you know the total was $30, you could have just done 30, take 30 divided by 5 parts. So if you know how much each part is, then you just times it for each person. So in our scenario, we know that there are 5 parts in total, but it's meant to be $30. What's 30 divided by 5 parts? 6. So each part is equivalent to $6. But since I'm getting 2 of it, 6 times 2 gets you 12. And then they just gets 3 parts, but each part is $6. So 6 times 3 is 18. That's another way to do it too. The reason why I didn't teach it that way is sometimes the number of parts doesn't fit well into total amount. And that's what the test usually does. Yeah, so we usually give numbers that don't fit nicely, and then you have to know how to do it fraction-wise. Okay? But yes, that's the intuitive way to do it. If you know there's a total number of 5 parts, divide the total amount by the number of parts, and then times it for each person by the ratio, and it works. It works as well. Okay? But that's 6B. So 6A was the simplifying, 6B is applying, and then we only got one more exercise on rates, and we're done for the term in terms of what you need to know for fractions, decimals, percentages, ratios, and rates. Okay, and then we've got a revision session. Then I'll give you a mastery task, which hopefully you have the weekend to do before week 9. Okay? All right, team, I'm going to stop there, and that's it for today. So make sure to keep up with what I've been giving you. You should be stronger with fractions, and you should now be working on percentages. Some of you can work on ratios and rates now.